Thank you everyone for joining. This is the session regarding progress in imagery stewardship. To start off, oceanographic imagery data like stills or videos or mosaics represent a strategic asset, providing an unparalleled visual record of the oceans, Great Lakes, etc., their ecosystems, and human maritime activities. These images support scientific analysis, environmental intelligence, policy decisions, resource management, and media usage. Collecting, managing, analyzing, and sharing this data presents numerous challenges. Accelerated decision-making, improving data centricity, and enhancing public accessibility is something that we all are battling, and specifically the standardization of metadata schemas. And this is a labor-intensive and a manual process, and today we're going to talk about some progress that we're making. We're going to highlight two presentations highlighting, again, the progress managing this data, specifically at NOAA. I'm Toby Kegley, a NOAA affiliate with CU Boulder's Cooperative Institute for Research in Environmental Sciences, known as CERES. I'm an Ocean Video AI project manager supporting NOAA-based task teams. We are working to collect recommendations for data management efforts in the imagery and AI ML space. Our work will culminate in a technical memo that we hope to publish this calendar year. And today I'm joining from Denver, Colorado. I'm excited to be here for my second virtual ESIP conference. Quickly, special thanks to you, Patty and Madeline, for the support on the ESIP side of the Zoom today. I'll pause for a moment. We'd love to learn more about you, the attendees. Please add your location, title, affiliation, and company in the link that Madeline provided in the chat. Great. As a note, we're going to use the Zoom chat to field questions today rather than the Slido for this session. So joining me are two amazing speakers who are driving change in how we manage our imagery data, including metadata management for archiving and annotation tooling that we use to identify what's being seen in the imagery that we collect. Our goal today is for you all to learn more about the progress that's being made. So one question for all of the attendees. Please enter in the Zoom chat. Do you collect or manage imagery in your day-to-day work? Thanks, Kate. Thanks, Josh. Nice to see you here. Awesome. Thank you. Great. We have a bit of a variety. I love to see it. Now, I'm going to introduce Vidya Gondal. Vidya is a close collaborator of mine. She's an ocean video software engineer who builds workflows and pipelines. She engineers these pipelines for NOAA's ocean exploration data and has for over 10 years. Her topic today will cover her work on enhancing video metadata pipelines at NOAA. And today, Vidya joins us from Maryland. As Vidya shares screen, please add any questions you have now or throughout in the Zoom chat. So Vidya, go ahead, take it away.
Yeah, just give me 1 second. I'm trying to share the screen. Are you all able to see my screen okay?
Yes.
Okay. Yeah, thanks, Toby, for the introduction. I'm Vidya Gondal. I'm from CU Boulder. I'm with Series, and I'm also part of NCI's OER data management team. And this talk is about enhanced video metadata management pipeline at NCI. So to get started with NCI's OER data management team has been supporting end-to-end data management support for data collected by NOAA Ocean Exploration Office for more than 20 years now. And this has included a development of a custom data management pipeline and a system for archiving and making the under video data publicly available through NOAA Ocean Exploration Video Portal. And this NOAA Ocean Exploration Video Portal is also called as OER Video Portal. And on the screen, if you see on the left side, we have this NOAA ship Oceanus Explorer that is owned by NOAA Ocean Exploration Office. And then we have the platform ROV Deep Discoverer that is used to collect the underwater video data. And on the right hand side, we see snapshots of NOAA Ocean Exploration Video Portal. The video portal supports queries on multiple parameters, metadata parameters like the keywords, observation dates, depth range, dive site names, expeditions, and so on. And the user can view all the results on the search page. And the video portal also has a capability to display the low resolution video so that the user can view the preview video before placing the order for high resolution video data. So going on to the next slide, here is a simplified overview of the OER video pipeline. And as you see, we receive the video data collected from the Oceanus Explorer, and it is sent to us, the NOAA NCI. And here we run many semi-automated video management steps to archive the data and make it accessible through the video portal. So this pipeline requires a person to run all these processing steps like archiving, manually moving voluminous videos from one server to other server until it is moved to the deep archive storage system, that is class. And then we also scrape the metadata information from expedition reports, dive summaries, and other input data that we receive from the Oceanus Explorer. And we generate detailed metadata from the annotations and the ancillary data. And once we have the annotations in place, these annotations are expanded using World Register of Marine Species just to make the discoverability more easier. And once we have the ISO metadata, it is published to Granule Geo portal, from which it can be accessible through the video portal. So at the end of the process, we have the data archived in the deep archive storage system, that is class, and the data is available through the video portal. And the ISO metadata that we generate is a fundamental piece that is needed for the search and discovery purposes. And this pipeline was originally developed with special attention to the Oceanus Explorer. So most of the scripts are completely custom to the file types, naming conventions, and the directory structures of those video data. But over the time, it became apparent that we needed to update our backend ingest process for a more sustainable workflow so that we can expand the same pipeline over multiple data sets. So this slide kind of emphasizes more on the metadata management because that is our key fundamental piece needed for the search and discovery. So as you see, we receive multiple input files that vary among the annotations. We have two different kind of annotations. One is the live chat log that is recorded during the expeditions, and the second one is the CTube annotations. And we also have the environmental variables recorded by different sensors on the ROVs. And we have the video data in itself. So we kind of extract all of the information present in these input files using time code. So the time code acts like a glue. So we kind of extract the information based on timestamp and add all the information into rich metadata. So each video segment that we receive has a rich ISO metadata record that contains information about that video segment, like the file name, the platform that is used to record that video, the keywords or the annotations that were tagged on that video, and also the environmental variables that were present in that particular video. And until recently, this process was kind of generated using custom scripts. which scrape the relevant information from the raw data files. But we plan to kind of improvise our metadata management approach. For this, our team is kind of in the final development stages of establishing a metadata database that will accommodate all of the OER generated video as well as open the conversation to further expand to include underwater videos collected by other line offices and programs as well. So, going to the next slide, the challenges that we faced were bulk reprocessing of the media metadata records is time consuming. So the bulk reprocessing is needed when we plan to add any post-truth annotations or when any changes are to be made to the metadata templates, like addition of any keywords or maybe unique identifiers related to that particular data set, or kind of revise the metadata. So in those cases, if we plan to reprocess all of the metadata, we would be generating like 100,000 records again, and we don't want to run all the scripts again that generate all these records. So it was kind of time consuming, and it became at some point it became very difficult to go back and revise all the metadata records that we had. And the next challenge is since we were scraping the information from numerous raw data files, any changes in these raw data files kind of broke the scripts, because the sensors kept on getting updated and the format kept on getting changed. So the recent scripts cannot be used on the previous data collected by the previous sensors. So we had to frequently update our scripts and at the same time kind of keep track of the previous scripts that we used to pass to the raw data files. And new sensors may require additional video metadata parameters. With the advancements of the technology, new sensors were being added to the platform, which implies we need to add more additional metadata parameters. But with this custom pipeline, we couldn't add any additional parameters because our template was fixed and all the metadata fields that we included were fixed. So we had to change that. Um, and in addition to that, many NOVA groups wanted to leverage this pipeline. However, since the pipeline was very customized to the Okeanos Explorer, we couldn't directly use it on the data sets received from the newer data providers. We had to kind of make some kind of modifications so that we can archive the data from other NOVA groups. So the new metadata database we came up with will try to address most of these challenges. So the solution here is the Fishflix application. So we developed a Spring Boot Java web application that assists with managing the metadata information in a database. And this application is flexible to be deployed either on cloud or on an on-prem server. And it is an internal Nova application currently deployed on NIH for the testing purposes. This application allows the users to add information about the cruises, dives, segments, platforms, and instruments, all of the information that is needed for the metadata, and store it in a database and also generate the metadata when needed. So setting up a database in cloud to store all the information definitely improvise the metadata organization. With the better UI, we also had better ways to enter the information into the database, and bulk metadata generation became a lot more easier because the user could directly export the metadata by just clicking some buttons. Because the information is already present in the database, we were able to easily export the ISO standard metadata XML records. And since we were storing all the information in one place, it ensured that the information is accurate and the storage is reliable. And it also avoided the redundant information. We kind of got rid of all the duplicate information in the database. And this storing the information in the database enabled sophisticated data processing more easier, because we have the information in the database, it is much easier to get some information about these video data, like, for example, total volume present in an expedition or the total duration of certain expedition can be easily extracted by running queries on the database. So we had a lot of advantages after putting all this information in a database. So with this development of the Fishflix application, we were able to replace all the command line tools over here with a single web application where the user can enter all the information. So the user can enter information related to any particular cruise dives and segments, and generate the ISO standard collection level and granular metadata. And yeah, if the user has any raw data files, the data files can be directly uploaded in the application, and the application directly passes through the sense raw data files and extracts the information and adds it to the database. So the improvements that we came across were reprocessing of the metadata is significantly easier, because now we have the information in the database. We could easily export all of the metadata records when needed. So bulk reprocessing is much more easier now. And this application provided a convenient approach to input all the information into the database. Like I said, there are multiple ways of entering the information. The user can directly enter the text into the application, or if needed, the user can also upload the input files, and the application will directly parse through all the input files and add it to the database. And the application can be updated with new sensor information on a needed basis. For example, if we receive the raw input data files from newer sensors, we can definitely expand our application to kind of gather the information from the new sensors and add it to the database. And our metadata is also very flexible. It can accommodate new metadata parameters. And lastly, we also had this modified schema of the database so that we can allow data sets from newer data providers. Previously, since our pipeline was fully tailored towards Okeanos Explorer, we had some set of metadata fields that are required for completing the archival and making the data accessible through the video portal. But since the data cannot be standardized over multiple sources, we kind of had to expand our schema so that we can allow the data from different data providers. So after this process, we kind of categorized our metadata fields into two categories, like the metadata fields, the basic metadata fields that are required for the ISO standard metadata, and the good to have metadata fields that are like if those fields are present in the input data, it is good to include those fields to improve the search capability of those video metadata records. So in this way, we were able to modify the schema and make it flexible to allow data sets from new data providers. And we were able to test on one of the Ruben Lasker cruises and make those records accessible through the video portal. But like I said, standardizing over multiple sources can be difficult. So we are currently kind of dealing with those issues, but we plan to kind of make it more flexible so that we can allow multiple input data sets from different NOAA groups. So the future goals of the application would be incorporate dataset from other NOAA groups. Like I mentioned, we have a lot of data sets incoming from different NOAA groups. We plan to kind of use this pipeline and try to incorporate all those data sets into our archival and make them accessible through the video portal. And in future, we want this Fishflix application to serve as backend search engine for NOAA Ocean Exploration Video Portal. Currently, all the metadata records are used for the search purposes in the Ocean Exploration Video Portal. So in future, we plan to use the database to serve all the search queries in the video portal. And in addition to that, we want to streamline the process to align with NOVA Data Governance Handbook and also AI guidance so that we can make the data AI ready. In and we are also looking forward to develop and use some of the video packager tools that can be used for archiving the data and directly feeding the information into the Fishflix app for the metadata purposes. And lastly, since we have a lot of metadata information related to 100,000 records in one place, I think at some point we can use this information for future development of AI and ML applications. So that's all I had. Any questions or comments, anyone? I also put my email ID and also our group email ID in here. So please feel free to contact us. Thanks.
Thanks, Vidya. Yeah, if anyone has a question, feel free to either raise your hand or throw that in the chat. Vidya, I do have a question. In terms of the level within the schema that you mentioned, can you elaborate on what those three levels are?
So we do have three levels of schema. We have the collection level schema that is used for the collection level metadata records. Then we have a deployment or dial level schema. And the third one is segment level schema. So usually we receive video data in segments. So we generate granular metadata for each of those segments. And the collection level metadata is generated for the entire collection, and that goes on the cruise level. And it is used to access the metadata records on one stop and other sources.
Thanks. I'll pause for a moment in case there are other questions. Vidya, we have a question. What kind of database are we using?
Yeah, sure. We are using the PostgreSQL database for now, and it is deployed on cloud, AWS cloud.
Thanks. I have a question for our attendees here today. Does anyone else in the session have a similar metadata portal or tooling that you'd like to share about briefly? Nope, no problem. Okay. Where are you, Vidya, in the development cycle? I know that you're making continual improvements. So talk a little bit about some of the dev work you're up to right now.
Yeah, sure. We were able to kind of modify and create the first version of the application. And the first version of application has been tested for the Ruben Lasker cruises, and it was able to successfully generate the metadata. And then we came up with a new schema just to expand our pipeline with multiple data sets. And we are currently in the development phase of Fishflix 2.0 that includes a new schema that can kind of expand our pipeline with multiple data sets. So the challenges we had were like sometimes the metadata fields can be very limited, like the data can be collected by the handheld cameras or something. So we need to be able to kind of archive those video data as well. And the metadata is kind of very limited because there is no information related to the geographic coordinates or maybe the timestamp of the video and so on. So in those cases, we kind of made some of the fields as optional, and we kind of included some required fields and some fields optional, and kind of are in the process of designing the next version of Fishflix that kind of allows the expansion of this application over multiple data sets. So the development is ongoing for the second version.
Awesome. And I know Ben is about to discuss annotation. And so I know you talked about the annotations video, and those are revealed as keywords on the video portal, right?
Yeah, that is right. So we have annotations that are present on the video portal. They are usually part of the description of each video segment. They appear on the description box of each video segment. And I think we have CTube exports for the annotations. And yeah, they are kind of tagged live using when the expeditions are being recorded by the scientists. Sorry.
Awesome. I'm going to pause again in case the attendees have anything to ask. Okay, Biddy, I think my last ask is there an internal effort to ingest, for example, Tater imagery? We're about to hear from, Ben at Tater. Is there an effort to ingest that imagery or annotations in the same sort of Okeanos video portal at some point?
Yeah, I mean, there have been discussions with the data management team about archiving the Tater imagery and annotations. But we plan to include it in the oceanographic packages, but I'm not sure if they can be made accessible through the video portal. But at this point, I think they are part of oceanographic packages at NCI.
Cool. Last pause for any questions for Vidya. Well, thank you, Vidya. We appreciate your time. We're excited to see. Oh, what's in the chat? Oh, just a thank you. Great. We're excited to see how this continues into the future, how it might help other teams at NOAA. We are thankful for your work on this, so thank you. If anyone has any takeaways they'd like to add in the notes document, feel free to add those for yourselves. And with that, I'd love to now introduce Benjamin. Benjamin Woodward is the CEO of C-Vision AI with 18 years of experience designing, testing, and deploying sensor and algorithm systems, including LiDAR, radar, acoustic, and optical data. As co-founder of C-Vision, he has worked to bring deep learning solutions to different domains, including the marine sciences, where he and the team have developed multiple systems for automatic video processing in both the underwater and electronic monitoring workflows. Ben will be highlighting how at Tater they are accelerating collaborative analysis workflows. So with that, Ben, take it away.
Excuse me. Thanks, Toby. Appreciate the invite to talk here. Thank you, Patty, for helping us get set up. And thank you, Vidya, for the previous presentation. Go ahead and see if I can share my screen as effectively. All right. I think before, fortunately, you were able to see my address bar, but I'm just gonna leave that there. So yeah, like Toby mentioned, I'm going to be talking about how we're able to facilitate and accelerate collaborative analysis workflows with our annotation platform called Tater. The name Tater comes from annotator. It's a little bit of a inside joke that just kind of stuck for a product name. So starting with a little bit about who we are, as mentioned, my name is Ben Woodward. I'm the co-founder, and on the bottom right there, you see my other co-founder, Jonathan Takahashi. We founded the company in 2016. We're a group of engineers, researchers, computer scientists, physicists, electrical engineers. Most of us started in the defense industry, and kind of what we do for fun ends up being the inputs that what kind of you guys do for fun. When I say you guys, I mean kind of marine scientists. So our outputs tend to be your inputs. Our experience, we've kind of got, as Toby mentioned, 18 plus, 20 plus years of building tools for various use cases, like I said, from defense, aircraft systems, underwater crewed systems, commercial fishing, and more. I like to put this video up because it kind of bookends both of our company right now. So this is well both the first and latest effort we've got going on. This is a trawl video that originally was just a stereo, or not a stereo, but a single video in a open cod end net where people were trying to do counts of different species. This is at the University of Massachusetts School of Marine Science and Technology. We have recently finished designing an upgrade with stereo cameras now, where we can actually do automated processing here, where you can see those boxes are getting rotated and the lines are automatically getting drawn. Because that is a stereo system, it means then that we're able to kind of automate the measurement for that. So that's just kind of a flavor of kind of where we started and where we're going around building out automated processes for the types of analysis that are required for things such as brownfish assessments or biological analyses. And in between is Tater, which is what I'll be mostly talking about today. So, what is Tater? It's our platform for basically end to end digital asset management and visual analytics. When we say digital asset management, what we mean is that we're able to kind of host and ingest massive media libraries. So, tens of to hundreds of terabytes of video and images that we're able to host and then make available to multiple teams. So we enable all sorts of things such as annotating the raw video data, associating with multiple metadata such as geolocation data or sensor streams, all of the types of metadata that you might have on an ROV or an AUV. And then we build experiences for analyzing and reporting, exporting all this stuff, doing QA, QC, and integrating algorithms. So a lot of what you'll see here are kind of automatically drawn boxes and segmentation masks that can then be QA, QC'd and turned into the types of reports that go into kind of what we're talking about. The way that we accomplish this is we built completely from scratch custom web-based video player. So we control everything from how it fetches the video to how it displays it to what the interface can do. Some of the features associated with it include kind of multi-resolution. This can be very useful. We're actually finding for a lot of people with low bandwidth connections. So you may stream a video at say 360p, but when you find a frame that you really want to annotate, when you pause, you'll automatically have fetched for you, say, like the highest 4K still that's available, but you don't actually have to stream that entire 4K video or download that 4K video in order to be able to get that part of the video. So this really helps for situational awareness. Um, we do things like being able to, scrub exactly to the frame where things happen. You might imagine that, if you're not exactly at the frame that you're wanting and you draw a box, if this wasn't a stationary coral or sponge, but rather a fish flying through the scene, your box, if it was off by one or two frames, would actually be nowhere near the thing that you wanted to capture. So it's very important for us to make sure that when we say frame 59, we always go to frame 59, not frame 1 second kind of near frame 59, which sounds like it should be easy, but actually it's pretty difficult. Uh, as I mentioned before, it's a unified data platform. So what that means is that when we ingest data, we don't just ingest the media, we ingest everything associated with it. So usually that could mean like CTD data. It could mean navigation data. So for ROVs, we'll take raw or filtered USBL navigation data, and then we can make that available on, say, overlays here where you get map overlays that have not just the navigation data, but each navigation point is associated with a point in time. You could click on that point in time and go directly to that point in a video and start annotating there. You can also overlay previous annotations that you have made or highlighted areas, say like a transect has started or on bottom, off bottom, or areas of high or low visibility. These all become things that are useful for people when they're trying to not have to watch hundreds and hundreds of hours of video in kind of painstaking detail, but really focusing on the areas where they need to annotate. So that gets us to where I'll be spending most of kind of the experience of collaborative analysis today, which is the mesophotic and deep benthic communities, MDBC, tater ecosystem. So that's a collaboration of a number of institutes. There's NOAA. There is a group called MARE, which is an acronym. I don't remember what it stands for. Temple University, the Smithsonian University, and a number of other collaborators who kind of come in and do things as needed. They collect various at-sea metadata, annotation databases, navigation and CTD data, and then they also have ROV video files, ROV image files, as well as AUV image files. And they all need to be basically organized in a way that there's relationships between them that their analysts can use to essentially help ascertain the health of the ecosystem they're trying to monitor. So that includes things like corals and inverts identification, fish identification, marine debris, habitat classification, or geographic classification, substrate and biological percent cover, as well as various measurements of the things. And then finally, being able to export all of this in a format that can feed to generally the modeling team for various habitat assessments. The way that we handle this in Tater, to make not things too confusing, is everything kind of gets its own data layer, or we call them versions associated with them. So annotator 1 may have data associated with corals and inverts or marine debris annotations, whereas annotator 3 is only focused on fish annotations. This allows you to kind of slice, dice, aggregate however you want, depending upon the report or analysis that you're trying to do, while still keeping your visual kind of interface relatively uncluttered. This is an example of the kind of custom QA/QC process that we built for MDBC within the Tater platform. That's one of the nice things, kind of, we think it's a nice thing, is that we're able to kind of basically customize every element of this by building applets on top of the kind of the core data model and infrastructure associated with that. So an annotator will come in, generate an annotation, which in this case is a box that has a label associated with it. After an annotation session is complete, they'll be basically randomly selected for a first pass of QA/QC review. Those can then be presented in a dashboard and gone through quickly in the review mode. An annotator can then respond to the reviewer comments, and it can pass along to the second pass of the QA/QC. And then again, annotators can respond to those review comments as well. So this is a process that MDBC has set up because of how they want to be kind of careful about doing their stuff, but we're able to basically set up any sort of QA/QC process that anyone would want to kind of have within Tater. So here's an example. I think this is an example. This is an example of that in process, right? So the reviewer will essentially activate the review mode when doing either their first or second pass. They can then go through and do a single click to then confirm or have a response required for each of these things. So when they load up this whole video, they don't have to essentially go through the whole video. They can just quickly scrub through to the areas where the annotations are that they need to review or provide responses for. And all of this information, as soon as it basically gets entered here, becomes the record available to everyone. So as soon as you enter this stuff here, you can see those check marks in the top. That means that data is now saved within the database. And the next time someone loads up a session, it's available for them to essentially verify or draw a report on or do all of that kind of stuff for them. Once you've kind of done all of that, then you would probably want to export it. So we created very specific filters associated with all of this stuff where someone can essentially go down by cruise ID and then apply by, say, very specific species that they're looking for. I should mention that similar to what was mentioned before about the World Register of Marine Species, we also use worms to kind of do our input for species names. So everything is gated on an auto select capability of their API for doing that. And then once you've decided kind of what cruise you want to do, what filters you want to do for various metadata conditions, we can do all sorts of kind of crazy combinations. So it could be species that are corals identified by user 3 on this cruise or this cruise below a certain depth, right? So you could enter that filter and kind of get those results for all. Then beyond kind of that stuff, we've made a number of custom tools associated with the platform that kind of enable the actual review process itself to kind of go faster. Right. So this video here is actually a stitched video of AUV imagery. So the AUV that they have actually kind of goes along this path and actually takes images every few meters. But because moving through images is the giant pain, we stitch those together in a video. Right. So what happens here is that when you find an area that you want to kind of get some situational awareness of, you can kind of look at all of the areas around it. In this case, they're going to be doing some various biological um, analyses. So in this case, they're going to be labeling what is the substrate. So they activate this helper that we created, and CMEX is based upon the percentage of an image that is covered by various things. So from here, we gave them a grid view, and then they can choose which substrate they're currently annotating. In this case, I think they choose Boulder. Should probably play this a little faster. But they choose Boulder and then they start painting. When they're done with that, they get an idea of kind of where they want to go next, and they fill in everything else with whatever they want to call it. I think they call it sand or mud or something like that. So you can just say, oh, everything else is mud. Right. And once you're done with this gets saved and it feeds into a number of essentially heuristic tools available for processing this. So CMEX itself is a number of rules for how you get overall classifications. In this case, also they're doing biological cover, so they're finding attached corals, I believe, or attached biota. They're using here a built-in algorithm within the tool called Segment Anything. This is a tool that was released by Meta, Facebook, and we're able to adapt it and make it live within the platform so that they're able to get those biological outlines really quick. They can then get all the kind of percentages they need for that. If this was a calibrated image, so if some of the images had, say, like ROV lasers, we would also then be able to do automated labeling or measuring associated with that. So not just percentage cover, but actual sizes of the various things. And then there's a whole bunch of other kind of custom attributes that they want to be able to say about each of these things. So, is the visibility good? What's the dominant substrate? What are all these things? These are all categories that their team has come up with because it feeds into the various modeling things that they do. Just kind of touching upon flexibility of metadata schema. As Vidya mentioned, it's kind of difficult if your schema is constantly evolving. So we actually accommodate this by using a mix of a fixed schema with a JSON B field within the actual database itself, which allows us to create this basically flexible custom attributes that you may want to still search over and see within the platform, but aren't first party database columns that require migration every time you change them. So that's kind of how we accomplish that flexibility and can have multi-tenancy within our platform for various users without having to have a database for each of them. So when a user's done, they essentially go through, do the process of selecting the frame, annotate percent cover, do the CMEX geoforms, do the biological percent cover, go through the same QA process as before. And then again, we have nightly automated reports for each of these things that then go to the modeling team. And then can then be packaged up for, as Toby kind of hinted at, eventually will, I think, go to NCEI for eventual archiving and availability in other areas. And that's my last slide. So a little bit of a short presentation, but happy to kind of revisit any of those points or kind of talk more about that, talk less about that. Yeah, thank you for listening. Appreciate the opportunity.
Thank you, Ben. I have a question. What does it look like as you export this data for a specific video in terms of end and out points for a particular critter or geological feature?
Yeah, so there's a number of different ways that you can handle that. So sometimes people may just draw a single box or note a single frame for that, in which case you may just get the thumbnail view of that. But we also have within the platform the ability to create clips from video. So you can actually just choose a start and end point, and we'll create a subset of the video that can either have annotations overlaid or not overlaid, that can then be downloaded and either shared for presentations or posterity purposes or what have you.
Cool. Thank you. Video?
Video, yeah.
Yeah, sure. So the video that is getting played in the application, is it a high resolution or the low resolution one? Because at some point you mentioned that the images are always 4K resolution. So
If they're captured in 4K, right? So we transcode them at a multi-resolution. So 4K images come in or video come in, we tend to transcode them at 4K, 1080p, 720p, and 360p. And then those become frame synced and available for people to stream depending upon their internet bandwidth, their computer, right? The reality is people going through VPNs on older hardware with, say, like a residential connection because they're operating remotely are probably not going to be able to stream 4K video. But what happens is if they can get an idea of where they want to annotate at 720p by streaming it, and then they hit pause, and what happens, I don't have a video of it here, but what happens is when you hit pause, it fetches just that frame at 4K and replaces the canvas with that. So you get the 4K frame when you're paused to be able to do kind of like zoom in and high resolution annotation. But when you hit play again, it'll go back to the 720p feed.
good to know. Thanks, Ben. And yeah, do we do this transcoding on the fly, like when the user selects a resolution?
No, we do it as part of the ingest process. So the transcoding happens during ingest because we have a pretty optimized and aggressive pipeline in order to make this stuff streamable. So we use a codec called AV1 for all of our stuff. A lot of this video, I would say most of this video, is actually probably captured in a codec called ProRes 422, which is not streamable. Essentially, it can be up to like 500 gigabytes for just an hour's worth of video. And when we transcode that to something that's streamable, we turn that into like 5-6 gigabytes for an hour's worth of videos, which is much more palatable for folks on streaming connections.
Okay, thanks.
Yep. I'm not looking at the chat, so if anyone's asking questions, I'm not seeing them.
I'll relay. Kate here has mentioned that she has a new appreciation for how complex the documentation for annotated video can be.
Yes, it can be complicated.
Yeah, I have another question in terms of feedback and user sort of iterations. Do you vet that like verbally in conversation or via email? How does that iteration process go?
Yeah. So we've been developing this process with the MDBC community for probably close to 3 years now. At first we had kind of a big development push to kind of get this stuff initially rolled out for them, but now they internally have monthly annotation meetings, and we have our main developer who actually, unfortunately, he should have been here giving this presentation, but he had a personal conflict that he couldn't get around. So his name is Mark Taipan, and he's done basically all of this work. But he attends their monthly meetings and kind of listens in, gathers feedback on any features or bugs they may run into, and then we kind of roll out changes as needed, and it helps us kind of continue to iterate, make the process better for them. We also work a bit with like the various I don't even remember all the acts, but NCOS and various other NOAA agencies that have their own kind of AI development stuff going on. And so we've used some of the models that they have created and integrated them into their workflows for this type of stuff. I see another hand raise.
Yeah, I was just gonna jump in with like a comment really quickly. on a project that I worked on a while ago, I was doing some stuff with computer vision for annotating videos related to like traffic patterns. And I know how much of a headache it is to annotate videos. So like, this is awesome. And it's just really exciting to see kind of the workflow you have set up here. And it's like really streamlined and efficient. And that's just, satisfying to see. And I know how tricky it is to do this kind of stuff. So yeah, this is great.
It's a funny thing because, we started off just kind of mostly creating algorithms for this type of stuff. And so our initial version of Tater was just an annotation collection platform. So drawing boxes. We quickly realized that people actually don't like drawing boxes on videos. It's boring and it's not the information that they want. So we kind of said, okay, well, we need boxes for our algorithms. So how can we make this better? And we realized that people are more willing to draw boxes if you make what they're actually trying to do easier. And that just kind of continued to turn into this, where today it's kind of the purpose around it is to kind of streamline all of these analysis things. The idea being I want you to spend as little time as you possibly can within my platform, because that means that you're able to get your job done quickly and get on with what you actually want, which is probably some sort of, summary or population count or geographical overlay that will help you fit into your research, right? If algorithms can help you along the way, then great, we're good at that. But if not, we can also just make it as painless as possible. Sorry, that's a little bit of a soapbox speech for that.
Yeah, totally hear you. Yep.
Kate looks like has her hand up.
Yeah, I guess I was just kind of curious. So with MDBC or anybody else who uses it, are people mostly annotating post-cruise, or are they doing it in real time?
It's post-cruise. So all of this stuff is post-cruise. We have with some other customers that we worked with done some near real-time annotation stuff where we've captured kind of like live broadcasts and then made them available to shore-based teams. But for this team, they tend to gather data, and then there's a ton of things that have to be done for even before they give them to us, post-processing and aggregation of the various sensor data, dive reports, all that kind of stuff. And so for them, it hasn't been something that has been a priority for them to do kind of in real time. So their lag is like 6 to 8 weeks, typically post-cruise, when they'll deliver this stuff to us.
Okay. And then my other question, you showed that you could, or like within the video, you can also overlay or simultaneously view data from the sensors, right? So from like water.
Yeah. So like that's what you're seeing right here, right? Yeah. So here, I can't zoom in on it. I don't have the platform open here, but this would be like, say, like a depth sensor trace, and these might be like so what we can do while we don't support at-sea annotation is we can ingest at-sea annotation. So if people are operating something and are creating, say, like like I said, transect start, transect stop, we ingest those, and those could be right here. Those events might be visualized so that you can see when important events of interest that were marked at sea actually happened. So all of that stuff does get ingested and then can be visualized and utilized for seeking to the various parts of the video that needs to happen. That's what you see here, right? All of this information tends to be either that kind of at sea gathered information or, pre-annotated information.
Okay. And then so that are people using, is that like C2 video basically, or C2 annotations that they do on the shipboard, or is that something else? I might
they have I don't know what their logging platform is. We get those annotations. They have a number of different things that they use. I want to say C-Log, but maybe it's not C-Log.
Yeah. But basically it's some other program, right? It's not you don't have like a shipboard version and then
No, like I said, we do have we do have, not with this group, we do have a group where there is a shipboard version where people will gather videos, and then they'll ingest them to their local server on board, but they have satellite connectivity, not to upload all the video, but the metadata can sync to the server while the videos get served on board locally. And then they resync those when they get back to shore, and we backfill the actual high resolution stuff. So they can actually do media playing locally on board within the platform, and then all of their metadata gets synced up to the cloud. When they get back to shore, they then ship the videos off to get ingested, and then all of their annotations magically just kind of match back up into the cloud platform.
Okay, thank you. It's interesting. Complicated.
It is. It is. But it's fun. Like I said, this is the stuff that I love to do. And I know that a lot of people like to actually do, I guess, real science with it.
Thank you.
Like to play around with videos.
Pausing for any other questions. Awesome. Well, we did have a third presenter who had something come up and was unable to join us. And so this concludes our session today. I want to give a big thanks to our ESA partners, NVIDIA and Ben, for being here with us. Thanks for the participation from all of the participants and the attendees. Again, if you have any takeaways, feel free to add those to the note. That's a Google document. And with that, I think both presenters shared how to get a hold of them. So if you have continued questions, feel free to reach out to me, and I'm happy to forward those along. I know it's been a long week, so thanks for your attention late on a Thursday. And with that, everyone have an amazing evening. Thank you.